Alright class, let's proceed. So now we'll start a new chapter. This chapter will be chapter 4 in your textbook. Chapter 4. And it's all about time response. Most material will be chapter 4 in the textbook, but we'll mix some from chapter 7 as well, okay, which is focused on kind of the steady state response. Okay, so since we now know how to linearize a nonlinear system, the rest of the discussions will be focused on linear systems, okay, linear time invariant systems as before, as we have always. Now, for linear time invariant system, we'll have external input u of t, and we would like to understand the output y of t. Now, the response is how the output signal y changes as a function of time. And usually, when we talk about time response, we focus on two types of time response. Okay. One of them is the steady state response. Steady state is the behavior of y of t when t is sufficiently large. So mathematically it means it when t approaches infinity. And this part is discussed in chapter 7 of our textbook. And of course the other one is sometimes you don't have that sufficient long period of time, so you want to know the intermediate stages, and what we call them the transient behavior. So just y of t as a function of time. And this part is discussed in chapter 4. Okay? In chapter 4. Now, when we focus our attention on the transient response, which is the focus of chapter 4, and this is our main discussion from this point and on. Okay? Chapter 4. We'll look at how things goes, right, as a function of time. And usually to solve y of t, there are multiple ways, and the most commonly used one is through transfer function, Laplace transform, and then your output y of t will be the inverse Laplace transform. So inverse Laplace transform of y of s. How to do the inverse Laplace transform? This is 3101. And in the first homework, you should have reviewed the material. Okay? The fundamental method is the partial fraction method. Then you can use, for instance, the cover-up method with the help with the building block signals and the tables to figure out the inverse Laplace transform. Okay? Now, for transient response, when you have different input signals, different u of s, different u of t, this y of t will be completely different. But for transient response analysis, we don't really have the time and efforts and capability to do all of them, to cover all of them. So we usually only focus on one input. That is our unit input and unit step response. And that is when our input is equal to the unit step signal. Okay, will be 0 before the start of your observation, and it will take value 1 afterwards. So graphically, this is their time axis, this is time 0, so we will have nothing before that, and time 0 we turn on this. And this is like a switch. It's, as you have learned this from the 3101 class. When you turn on the switch, the system starts to respond. Okay, it can be turn on the switch of the light, of air conditioner, of your car, of a robot, of electrical or power transmission network, or more complicated systems or devices. Right. So this is the behavior we want to study. Turn on the switch, how the system will respond to this switching on command. Now, this is a very standard signal, so its Laplace transform is also very easy. It's just 1 over s. This is the Laplace transform of the signal. Okay. In addition to the input, we also only focus on we cannot discuss all systems because some systems will have sort of meaningless result. For instance, if you enter the signal into an unstable system, then eventually things will blow up. And if things will blow up eventually, in most cases, it doesn't really make sense to study the intermediate state, how it blows up, right? So we only focus on and only discuss asymptotic stable system. Okay, we only discuss asymptotic stable systems. Unstable system, it's fine, but asymptotically stable will be our main focus, and well, we'll discuss very likely about marginally stable systems as well. Okay. The main focus is asymptotically stable system. This is our main focus. So what are the methodologies and how we really can study all of this, right? This is the main issue that we need to focus on. Now just to quickly remind us of what we're going to do, let's look at the Laplace transform methods when we want to calculate the response of the signal.